tests. So one thing which I've been meaning to have a play with is one of these, which is a Raspberry Pi RP2450 based ROM. So it can emulate a whole series of different ROMs, and if we have a look here, you can see it's got quite a few different versions available for the different ROM types that you might want to use. They've got some pretty funky features. I'm probably not going to be going into those. There's not a review of these. I'm just having a go with one. I've bought a few of the different sizes, and they come with the main piece itself. You get the pin headers, and you also get, if I can get them out of the packet, some jumpers which can be used to flip between different ROMs, although he has got a sort of grub-based bootloader type thing. I think that he's just released that allows you to flip between different ROMs, like by holding down a key on the keyboard on your device, rather than use the jumpers. So you can buy them pre-built. I think there's a few people that are doing them pre-built if you don't fancy doing the soldering. But what I wanted to have a play with is replacing one of the edit ROMs on a PET, because I've been having a little play with the PET test ROM to make a couple of changes to it, because whilst I was testing it, one of the things that I noticed is that there's no delay at the start when it does some of the graphics tests, which means that the monitor's not warmed up. So unless you put a reboot button and wire it in, you can't actually see the first set of tests. So I wanted to put a delay in at the start, and I also wanted to have a little play and see if I could also add into it the IE port tests, which is just the sort of basic read and write tests that at the moment there's like a sort of 80 line basic program that you can type in really laboriously in order to just check that you can read and write over to the IE interface. So I thought maybe I can get those in, but in order to do that, I need to be able to have a little play with the edit ROM. So I thought it was a perfect opportunity to have a play with one of these. So let's have a little look. That's what you basically got. So not much to it, because he's using the fact that the I think any of the newer chips are 5-volt tolerant. So obviously not, don't natively support 5-volt per se, but they will work okay in a 5-volt environment. So I'm going to get these assembled, and then I'm going to pop that in a PET, and we'll see how we go. So one moment. Right, that's all together. Just pop it out of this socket I was using just to Keep the legs lined up. You. So snap all the little legs off. There we go. And in theory, there's a little web interface that you can actually use to program them. So let's grab a USB cable. Let's see if it's still alive. Okay, we got a little light. So let's have a little look at this. So, getting started. Web, device information, connect. That's not particularly promising. Oh, yeah, there we go. You can't see that. That's right. Yeah. And there we go. Yeah, 2350. Right. So I haven't got my ROM set up yet. So I'm not gonna go much further on this yet, but that's ready to go. So I'm gonna go and have a look at the code for the pet test ROM, see if I can make a couple of little edits, and then we'll pop this in one of the pets and see if it works. Or in a moment. So in the standard scheme of things here, I've not read the instructions. I'm just going to wing it. So we're connected up to the Fire 24, which is the 24-pin One ROM. We're going to do a custom ROM image. I'm going to go and grab the ROM file that I want. The ROM is a 2716, and we've got an option here of no special handling, errors if the image size does not exactly match the chip, which is not I don't know what chip it means. Does it mean the 2716 or does it mean the actual One ROM? Duplicate, truncate, and pad. Pads the image out with extra bytes to fill the chip size. Now, that image is exactly the right size for a 2716, so I'm just going to select none for that, and then I'm going to do that, and I guess that. Okay. Right, so in theory, that should behave like that. I know what I could have done actually to test it. I could have put a ROM image that I knew what it was and then read it back with the retro chip tester, because I haven't got my other programmer plugged in at the moment. Maybe I'll plug that in and we'll give that a read back and see what happens. 1 moment. Okay, right. Let's try just popping it in the EEPROM reader and writer and see if we don't explode it. So one thing which you need to be a little bit careful of is the pin 1. So the pin 1 on these ones is right up there on the corner there where you got the white mark. So that goes this way up on this. Make sure I've got it in right. That looks right. Okay, so let's have a look at this. So it's 2716, so yeah, let's say it's that AMD 2716. So this is gonna error probably on a few things. We've got pin detect and verify. Now, one thing you've got to be really careful about is that you do not try and write the ROM using this, because as you can see down here, you're going to belt 25 volts and 6.5 volts into this, and it's 5 volt tolerant, so it'll set on fire. So read, and I'm expecting this to complain. Bad pin. I'm going to ignore that. Ignore and continue programming. That's slightly worrying because it better not be programming. Okay. Back right. Yep, that has read, and we can see up here at the top, pet tester. So that is reading correctly. Okay, so that's a bit of a relief. I don't think I've set it on fire, but yeah, generally speaking, you don't want to put these anywhere near one of these because you program them via the USB. You don't program them via one of these, and you can probably read back and verify using his toolkit or something. I don't know. But yeah, okay, so I haven't bothered adding the extra pin headers on there, which I'll show you. Ooh, there's a slightly bigger one, which I've got the pin headers on. And you can use this if you want to manually swap between banks, because these can hold multiple ROM images in one go, and then you can flip between them. So if you want to say have like a test ROM and then the original ROM, you could just flip between them using that. But like I said earlier, there is also another way of doing that, all completely in software, so and you don't even need any jumper wires or anything. But I've not looked into that, and for now anyway, I'm just doing one ROM, and I'm just using this so I can put multiple different versions on without pulling the chip in and out, because I can leave it in place on the board and then just plug the USB in and program it in place and update it. But yeah, right, let's pop that in and see what happens. Right, so here we go. Nice little lightweight pet, and just double checking that it is working before I open it up. And it's probably gonna have. Ooh. Right, and the bottom one here is the edit ROM. So let me grab that out. Give it a bit more light. Oh no. There we go. And then put this fill in. I've got slightly bent legs. Okay. We are in. Now, moment of truth. Okay, so that is not booting. So I need to try something else. So I went to get the schematics to work out what I was doing wrong, and then I realized that the reason why it probably wasn't booting is because I'd pulled out the kernel ROM, not the edit ROM. So let's try this again with this in the edit ROM position, not the kernel ROM. In one, that's there. Okay. Try again. Oh, yes. Yes, 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 yes. Okay. So we're booting. Then the other thing that it's supposed to do, which it's clearly not working, is the test for the IE port. And if it detects that everything's okay, it should be 0000, and it's not. It's 0012, which means it's not working, because I know that the communications are working fine on this. So I'm going to go back over and work out what I've done wrong and have another go with that. But that is now booting correctly off the One ROM. I can just plug my USB cable into that without having to keep pulling it in and out, and have a little play with the different versions. But that's okay. That's part way there, because yeah. So this timer. So what I'll actually turn it off, and I'll show you what the issue is with the original test ROM. Is that you power it up, and it then immediately displays the test thing, which doesn't give enough time for the screen to warm up. So what we've got there, obviously the screen's been on, so it warms up quite quick. So it's those screens there, and you want to record them and probably pause them if you're having issues with them, to then be able to identify. But if you don't have a pause, or if you haven't built yourself a reset button, you can't get those front screens. I mean, you could if you're using a capture device rather than the CRT, but I think that's quite a bit better. And this is a slightly newer version of the one that I had previously, which that goes and grabs the first few bits of each one of the ROMs, so you can see if you've got an issue reading them. These are the CRCs of the ROMs up here. But right, anyway, so partial success. It's at least booting with the edited ROM, but yeah, that test isn't working. So let's have another go. Okay, I think we've got somewhere. So managed to iron out the issue that it had trying to identify the faults on the IE488 bus. And what we've now got, if I show you it booting from cold, I've also put a bleep on, which you might have heard there, which is just helpful to just see that it's booting. So we've got the countdown happening to allow the CRT to warm. That now warms. Now down here we've got 001D, which indicates a fault, and the first two lines are the data line, and the second two digits are the control line. So that's saying that we've got an issue with the control line on this machine. Now I know, let's power this off, that I did have an issue with the control line on this machine, and it was because I had a faulty 344 buffer chip up in the corner, which I've put back in to test this. So because it's all socketed, if I get that back out again, there we go. So we've got that one out. Bent all its legs, but it doesn't matter because it's a dead chip. There. And then if I put back in the correct one, which you can see, very dark in here. I think that's back in. If you pop that back down, we run the test again. Then we can see that's 1K4 just off the screen there, which is 1K RAM detected. And now we've got 0000. I've also tried pulling out, just removing one of the other buffer chips off from the data line bit, and we correctly report that on the first two. So this does now seem to be working. So I'm pretty happy with that. And the One ROM has been working brilliantly. So, you know, you can, while the machine's on, I can plug straight into this. It says being unable to plug into it. And you probably just heard there, it's gone straight into programming mode, and I can program it. I do have to power off because when I remove that, it hasn't moved back into ROM mode. So I do still have to power cycle it. But that's been really helpful. I'll have another check over this, and I'll probably throw the code back at Dave who made the original one, just because there's a fair chance I've done something wrong. Also, by adding in the small detect at the beginning for the 4080 column and the little tone for the bleeper, which I think I don't think some of the earlier pets have got the bleeper, so that would probably only be for the 40 series and after. But I quite like it. There's now 0 bytes left. I wasn't even able to put pet tester signature at the bottom of the ROM. There's only enough space for pet test plus. So there's not really much room left to do anything else. I've left in the additional bit of code that was done by another chap there, which is outputting the first few bits from each one of the ROM chips that it can see. But I'll leave it at that. I'll post the code up on one of the forums, see what he wants, but that's great. Right. Well, this didn't go quite as smoothly as I expected. So this is the 80 column multi-font machine. And so in order to test that ROM, to check whether it was flipping between 40 and 80 column, I thought, oh, let's give it a go in this, because this one's working fine. Well, this one was working fine. So got it out, powered it up, completely dead, nothing in there. So pulled the edit ROM out and popped in the One ROM, and initially it booted, well, I'm going to say fine, but it booted into the second test, which showed a memory error. So let me just show you what that looked like. So you've got a series of goods, a series of bads, and then we've got the second part of the test where we've got the series of dots, which are good, and then we've got the alphanumeric characters, which are bad. So we've got good, bad, good, bad, good, bad. And if you wanted to count them, there's about 64 of the G's, and then it flips into bad 64, 64. So 64 would indicate that we had an issue with data line 6, because that would be 0, 2, 4, 8, 16, 32, 64. And so I've started, I got the schematics back out again, and I started having a little poke. And then whilst I was looking at it, we seem to have entered into failure mode 2 now, where it's now broken even more. And I'll show you what it does now when I turn it on. Let's flip over to this one. So we've got the warm-up delay in there at the moment, which you'll see coming in a minute. So we've got 1K0 and then the countdown. Now 1K0 isn't right because in the ROM where I've set that, it either says 1K4 for 40 column or 1K8 for 80 column. So 1K0 means it's trying to display 4 but displaying a 0. And then what we've got here is the first test, and normally the first test flicks up and it moves on to the next test. But in this one, we've got it where it's just cycling through the first test, which is why it's so flickery. But we've got the first character flashing away all over the place. And that would suggest we've got an issue there with bit 0, and that this is a video RAM test, whereas the other one was testing the main system RAM. So now it looks like we've got a video RAM problem. And if we open this back up again, that would point us to, if we have a little look at the schematics, I've got the red marks here from the other machine because quite a lot of this had failed. So you've got the RAM here, and this extends onto another one where you've got the odd and even RAM sections, which is whether you've got a 40 or an 80 column machine, whether it's got the extra 1K of RAM. And so we're looking at potentially a sort of, in here you've got ESD0 issue, which shows that should be on pin 14 of the, in this case, the left-hand side of the evens, but also that same ESD0 is going to appear on this one here, where we've got CSD0. And if we check with the oscilloscope and have a little look, count back from here. So here's the RAM chip. So 11, 12, 13, 14. So that one's fine. I'm not sure if you can actually see that. 11, 12, 13, 14. So we're okay on these ones. 15. It's fine. These are all looking okay. Okay. 10, 11, 12, 13, 14. 11, 12, 13, 14. Okay. So there we go. So pin 14, and probably this one should be good. 10, 11, 12, 13, 14. This one's bad. 10, 11, 12, 13, 14. This one's good. So we're seeing there that we've definitely got an issue on pin 14, which is, as per this diagram, that is ESD0, and the other pins are all okay. And we've got that on UC4 and UC6. I think I'll just double check that. Yeah. So we've got that on UC4 and UC6. Yeah, so it is here, exactly as it says here, UC4 and UC6. So I'm guessing it's unlikely that both of them are wrong, but if one of them's failed and is holding the dateline 0 down, then they'll both They'll both be wrong. So I think what I'm going to do is I'm going to socket these anyway. They're fairly common failure point from what I can tell, and I should have quite a lot of the chips for this, because when I was testing the other one, I bought a few different types to try and see if I had a timing issue, which actually turned out to be the character ROM in the end. But also, when we pull these out, we can just jumper them and hard set them to get patterns onto the screen anyway, which will then help us diagnose where the next issue is. So I'm either just going to socket all 4 of these, or I'm going to pull UC4 and UC6, but that means I've got to get all of this board out of the chassis. So one moment, please. Look on the microscope, double check we haven't focused this in. Okay, still a couple with some soldering, but it doesn't look like any of the traces have been damaged. So got the retro chip tester. See what this thinks of these chips. Okay. 2114s. Okay, so happy with that. Okay. So they might all be all right. Yeah. Okay. Bit too soon. Right. Okay. Build. Okay. So we did have a faulty one. Those three are testing as all right. Like I said, I'll have a load of spares, so might replace all of them so they're all running the same one. Some slightly newer stuff if I can find them. But I'm gonna clean that up. I'll clean the chips. I'll pop some sockets in, and I'll be back. Okay, they're all cleaned out now. Just about. So let's get some sockets in. I do actually have a polarized filter on this, but because I've got my other lights on, it doesn't work. Okay. That looks all right. Right. Cleaned it. Sponges. Mm. That's these things. Not sure if they seem to work all right. Don't leave fluff behind. Right. Yep. Looks good. Right. Now we go see if I can find some RAM chips. Oh, the most irritating thing ever. This is my bag of chips, which, if you have a look at these are, there's one original here, and then all the rest of these are these things that you seem to get from China, which are perfectly good 2114 chips, but they've sanded off the top so that they can put the same NEC branding or anything like that, which is so irritating because they're clearly like new old stock chips and they work and they test fine. Well, some of them do. It's always worth checking them before you put them in. But you can't tell what they actually are, you can't tell what the timing is. And with some of them, where you've got different addressing, you actually, I mean, you really should be checking the specifications of them, but you've got no idea what they actually are. So I wish they'd just leave them as they are. Even if it meant that I got like 12 different types, at least I'd know what make they are, what timings they've got, that kind of thing. But let's get these popped in and we'll see if that's fixed the problem. Okay, back in. Not really screwed in yet because I'm expecting to need to pull this out again in a minute. But let's put this down so you can't see the smoke coming out. And let's power it on and see what happens. Ooh, focus. Okay, well, it's at least booted. Okay, come on. Get in focus. Right, okay. So we're now back to the original fault that I had previously. So that's cured the issue where I've had the video RAM fail. But now we can see we've got a whole series of goods. Then we got bad, then good, and then bad. And then when that stops, we're on to the next set of tests. And because this looks like 64, 64, 64, 64 for the first section of the test, of the 256K, that suggests that when we flip over at bit 6, we've got an error. So that could be, it could be a RAM error. It could have a faulty chip, or it could be an issue on the bus somewhere. So I'm gonna have a little poke around and see where I get to. Back in a bit. Right. So I think we've got an issue with address line 6, which on here, so there's the RAM. Have a look at this. So we've got all the address lines coming in across all of the RAM chips, and address line 6 appears to be the one that we've got an issue with, but I couldn't see anything unusual when I was scoping that. But I don't know whether this is now different, having fixed the VRAM issue, and I don't know if that was impacting this. I don't think it can be, but if I have a little look here, so these are the address lines going on here. Let me just see if bear with me 1 second. Let me shift this camera over and then that gives you a slightly better view of that. So if we have a look over here, so these are the address lines here, and they don't look particularly weird, even address line 6. But just having a poke, and that doesn't look good at all. If we give that a reboot, there's the reboot, and then we see a little bit of activity, and then we're back to that. Now that should be the read write, RAM read write, and that just doesn't look good. Now these are the same Chinesium RAM chips that we've got here that were swapped out, and this has been upgraded, so it's been bumped up to newer RAM chips, which should be more reliable, and nothing feels overly hot. There's definitely something not happy there. So I'm going to grab the thermal camera, and we'll have a little look. So let me grab this, grab the phone. Come on, you can do it. Okay, here we go. Right, let's flip over to this, and yeah, like I said, nothing seems overly hot, but we do seem to have, what are you saying? An overly cold. Is that a good press? Right, okay. There's that one, which is UA7. Okay, right, well, let's just pull UA7 out then. And have a look and see what that says. In fact, I might as well just grab a replacement. Let's power this down. One moment, let me dig my chips out. Okay, got a few here. More Chinesium. Let's grab this UA7. Get this to connect. There it is. Not working at all. Not so much for an actual chip puller. That's useless. Yeah, UA7. I have not tested these. Let's just pop one in. I mean, this has got a 4164 upgrade, and these are supposed to be, the reason why I did this is because they should be way more reliable, because they just run the standard 5 volts. Okay, well, power that on. And there with 3, 2, 1. That's made no difference. So we've still got good, bad. So that is exactly the same. Let's pop the thermal camera out again. Quickly check if we have made a difference. It could be that there's somehow a damage trace or something. Right, let's grab this. Starting back up. Okay, let's have a look at what we've got. So there's UA7 there. So that is now powering up. So that looks like that was an issue, but that was not the issue. So that's weird. So a whole series of issues. And it was just sat on a shelf. It wasn't running. Let's have a little look at what we can see on that. It looks the same. Might have to dig the other one out just to have a little look, just to see if that's normal, because it doesn't look normal. Okay, anyway, I'm going to get back to diagnosing the address line fault. And the address on this runs through the same 3 buffers that do the RAS-CAS and address lines, and they feed off to various other sections, including, I think, something to do with the jumpers here and the jumpers here. So I'll have a little look through the schematics and see what I can come up with. One moment. Oh, hang on a minute. You know, I said these were untested. Yeah. Bail. I bet this is a selection of. Here's the next one. Yeah. I've got a pile of dead ones that I haven't marked. Right, so we had 5 of those were faulty. I've put them all together. That's useful, isn't it? Which I bet means if we have another go with that, if I pull this one. Not working very well, that. Okay, what's the betting? I reckon 100%. Yeah. Okay, I have got some ones that I know where they're tested here. That one's actually got the little bodge you can do on, so that you can get the 4164s to run. Bypasses the 12 volt. So let me just very quickly, let's just do a quick check on one of these before I put it in. Yeah, they take ages to test. Can I cancel it? No. I'm just going to reset. I'm going to wait for that. Okay. Let's put one that actually works then. I think this is a real one as well. Woof. Imagine that. I'm sure I've got a load of these kicking about somewhere. I'm going to go in. Let's just give its legs a little squeeze. Okay. Right. Okay. What have we got? Okay, 3, 2, 1. Ah! And there we go. That's the actual change 0000. So that was it. In theory, if I pop the original edit ROM back in, that should just boot into basic. I might have a little go at seeing if I can get the keyboard to boot a different ROM, like a little bootstrap feature, which I know that Piers has just recently added into the One ROMs. So I might have a little go at that, see if I can dual boot the system. But we're working, and what that also shows is that the ROM is correctly working, at least on this PAL 40 series, so the 4032 40 column and the 4032 80 column machines, and it's correctly identifying the RAM and doing 40 or 80 column, and all the tests seem to be working. I'll leave this running in a bit to go through it. One other thing which I do need to do on this, which I think is partly responsible for the slightly wavy screen, is the thing that had actually failed on this is the filter had blown, and I've got some replacement filters, not the same as the one that came out, but the values are roughly the same. So I might try popping one of those in and see if it helps clear some of this interference up, if that is what the issue is. But for now, excuse me, I think we're done. I'll pop some more info up about the ROM, and I'll have a chat with Dave, see if I've missed anything out or anything that needs updating. But anyway, that was interesting and an unexpected repair. Thank you very much. And we have a look at the chip that we had a problem with, which was the UA7 chip here, that I was originally attributing the issue to an address line 6 issue, so your FA6 line coming in here on pin 13, when really, if we have a little look over here, we've got D6, which is a data line, and that goes to UA7 and UA6. And because of the pattern that we had, it looked like there was an issue, something to do with a bit 6 issue causing the repeated pattern. And I was just a bit too quick to jump to address line 6. And when we looked at everything on address line 6, it all seemed fine. It was booting, the video was displaying correctly, which should have then just immediately pointed to it either being UA6 or UA7 RAM chip that we had a problem with, which showed up pretty quick on the thermal camera. But yeah, probably could have skipped most of the address line tests if I'd have just had a little think. But yeah, okay, right, well, that's enough of that.